So this morning session is led by one of our own, and he's a seasoned full stack developer, test automation expert, and HRD Corp accredited trainer with over 10 years of experience. Having trained over 500 professionals or more and worked with tech giants such as IBM, Cognizant, he's known for transforming complex topics into practical, hands-on learning experiences. So whether you're here to upscale or stay ahead, so I hope everyone is ready for an engaging and a valued back session. So please help me welcome Sir Deepan.
Yeah, very good morning, everyone. Thanks for the intro, Tony. My name is Deepan, and I'm going to be the trainer for this session. Um, can we start?
Go ahead, sir. The floor is yours.
Yeah, I'll share my screen. Tony, you need to stop share for me to be able to share.
Sorry, sir. Go ahead.
No, no problem. Thanks. Right. So this is what we are going to do today. We are going to see, we are going to do containerization using Docker. Right. So basically, we are going to see what is containerization, and then and what is Docker, and then how we are going to use Docker to do something called containerization, right? And we also see how relevant it is in the modern world, the containers and Docker are in, right? I believe many a time you might have heard terms like containerization, containers, images, Docker, Kubernetes, something like that, right? So this is about getting ourselves introduced to these concepts, right? Um, so though we can't able to go more in depth in terms of hands-on in this session, but the idea is, like I mentioned, or rather the objective is to introduce everyone to these concepts so that you can take this learning and then take forward for your advanced learning, right? Yeah, so like I mentioned, my name is Deepan. I'm a software architect presently working in Garanto, and I have more than 10 years of experience in the field of software industry, and also I am an HRD Corp accredited trainer. This is a basic summary of what we are going to do. Basically, we are going to see what is Docker and how it is useful, um, how you can run a Docker container, and then how you can build and share image, and then how you can run multi-container applications. Right. So a small glimpse of what exactly we are going to do in terms of hands-on. Right. Right. So we'll start with this. Before we get into the topics, if I have anyone who wants to share or ask anything, you can probably go ahead before I continue. Or do you have anyone who has previously worked with Docker or any other related tools earlier? So you can also use the chat before we proceed. You able to hear me, right? You able to follow me? Can I proceed with this speed?
Yes, sir. It's all right.
Yeah, great. Great. Yeah, thanks then. Um, yeah, I think we will continue. Right. So now this is a scenario, right? So the scenario is we need to run our application in diverse environments, right? So for instance, the application that we are building. Um, so as a developer, we need to run the application in the developer environment during the development, and then it has to be moved to the production environment where it has to run the similar way in similar manner in which it has run in the developer machine. And then for testing purpose, it might also be running in a staging environment, right? And then it has to run in the client environment when it is getting delivered, right? Um, So it has to run in different environments. The application that we have built as a developer, it will be moved across multiple environments. And then the thing is that it has to run consistently across all these environments. Right. So like the way it has behaved in a developer machine, it has to behave in a similar way in the other machines as well. Tester machines, client machine, and then the staging environment, and then I mean the staging machine, and then the production machine as well. Probably it might be a cloud virtual machine, something like that. So wherever the application is getting deployed, the same application which work very fine in the developer environment, it has to behave in a similar manner consistently across all these environments. Right. So now, do you think it is a easy task, or it will, it will work as expected? Right. So now this is a scenario running an application across diverse environments. Right. So now, what are the things that needs to be considered? Right. So application needs to be deployed across multiple environments. The application has multiple components, right? So the application, it might not be come as a single unit. It might be come as a multiple unit, right? So for instance, in a typical full stack applications, it will be having a backend, it will be having a front end application, it will be having the databases that has to run along with it, right? It will be having a scheduler app, something like that, right? So the application has multiple components, right? And then each of these components require different dependencies and configurations, right? An application with all these things, so we need to manage all these things consistently across all the environments, right? So now this is the typical things that we need to handle when we try to run an application in multiple environments. So primarily it is required to be run in multiple environments. So that is the case. And then what are the things that needs to be considered is this. Right, so it has multiple components that are need to be managed, and each component requires multiple dependency that are to be managed across all these machines, and then it needs to behave consistently in all these environments. Right, so now the challenge here is, right, so like you see in this simple diagram, right? So all these things, the applications and all these components with all these dependencies, it will which was working in machine A might not work in the other machines, right? So due to different setups, variations in different setups, right? So this is a classical developer problem, right? So where application works on one machine, and it will not, the same application with same setups and things, it won't work on other machines, right? So that might be because of difference in fundamental configurations, broken builds, right? Stuff like that, right? So dependency error, package version conflicts, build fail, right? So these are the things that we as a developer might come across very often, right? So earlier, right, before the era of Docker. All right, you might be getting phone calls from the other team members saying that the your application is not working in my machine, right? And then we will be saying no, it's not, it is working in my machine. It should work in your machine, something like that, right? In order to handle this, we even specifically deploy resources to manage this. So we'll send our resources to the on site, and then he will be managing these things, right? Specifically to manage the application deployments, we even need to depute a specific resource to do this, right? To install the dependency, to fix the dependency, primarily to manage application in the other environments, right? You able to follow me, right? Can I continue? Any questions here so far? Yeah, great. Right. So now this is a challenge, right? So now what is the solution that we have is something called containerization, right? So the solution is containerization. All right, as you can see in the picture, instead of exporting the or rather distributing the applications, we are distributing the containers, right? So now that, so earlier here we need to distribute the applications. The application that we want to run, that application alone we are actually distributing it, and then it is up to the end user, whoever it is up to the stakeholders to handle the the other setups. Primarily the application alone is getting distributed. Rather here in terms of containerization, we are saying containerization as a solution to address this inconsistent working of application, right? So how containerization helps here is that instead of porting the application alone, we are porting something called container. So basically, this container is a isolated unit that basically contains the application along with all its dependencies and then the build configurations, right? So for instance, you can see here, it is a container. This depicts a container. This basically contains the application or code that we want to run, and along with that, it will also contain other applications, whatever dependent applications that are there. It will also be there along with the libraries, configuration, setup, whatever it is. We are actually porting all together whatever that is needed to make that application to run smoothly, whatever that is required, configuration, setup, right? So we are actually bundling it together, and then we are calling it as a container, and then we are simply porting the container, right? And then here, if you could see here, the container is what is now we are porting to other machines. So now as an end user, the only thing that he needs to do in order to run the application is simply need to pull the container and run the container. That's it, right? Pull the container, run the container. He don't need to worry about any setups, dependency, configurations, right? Expect resource to install and handle the applications. That is not the case anymore, right? Because all those things are already done, and then it is being built as a container unit, right? So whatever that is being required, that is being bundled, and then this bundled unit is what is now being distributed across. So the end user now, you don't need to worry about the dependency build. You simply need to run the container to run the application, right? So this is the idea. So this is the idea. So how basically this works, right? So what exactly it is? So containerization is the process of packaging an application along with its dependencies, libraries, and configuration files into a single unit, what we are calling it as a container, right? Now instead of application, we are packaging our application into a isolated unit called container, right? As you can see here, this is a typical depiction of how this thing basically works, right? um, so this is machine A. Inside machine A, we are running the container. The container typically will have our application, right? So now our application is running in an isolated environment. We are calling it as a container. So containerization is the process of packaging an application along with its dependency, libraries, and configurations, right? So without this containerization, these are the things that are to be managed, right? So if you have to repeat, these are the things that needs to be managed across multiple environments, right? Dependencies are to be managed, libraries are to be managed. So individual dependency will have its own versions. When new version comes, we need to manage the new versions, all those stuffs, right? So now these are actually handled once and then built as a container, and then instead of porting the application alone, the container is getting ported, right? So containers are typically lightweight, they are portable and self-sufficient. They provide a standard and isolated runtime environment for the applications, right? So it provides standard isolated runtime environment for applications, right? So how basically it is lightweight, right? How basically it is lightweight, right? So these are the characteristics. It packages application with all the dependency, the primary characteristics. The container will consistently run across all the environments, right? So provided the container engine, the container typically will be able to execute consistently across all machines, right? So containers are lightweight and portable, and so essentially, they are consistently deployed across multiple environments, right? So this is a typical container architecture. Right. So container is a kind of virtualization, right? Container is also a kind of virtualization, right? So through virtualization, what we have is a virtual machines, our traditional virtual machines, right? In a traditional virtual machines, we have a single machine with a single operating system, and then we have a software called hypervisor. That hypervisor will split the physical resources into multiple resources. Something like a single CPU can be logically viewed as multiple CPU. A single RAM can be logically viewed as a multiple RAM. A single storage like SSD can be viewed as a multiple SSD. And what we will do once we are able to logically split these resources is we can create logical environments, so what we call as virtual machines, right? So this the process of splitting the physical resources is what we call virtualization, right? So this is also a kind of virtualization. Containerization is also a kind of virtualization, but instead of going with a typical virtualization process, it takes a more softer approach, right? So what exactly this does? So underlying, if you can see here, underlying. So this is what makes containers as lightweight, right? So that is where we are saying this container architecture. So we know what is containerization, and then we know as a entity what is container, but we don't know what exactly the container is, right? So a container is a lightweight virtual machine, as we can call it, right? So containerization is process of virtualization. It is a lightweight virtualization, and a container itself is a virtual machine, but it is not a traditional virtual machine. It is a lightweight virtual machine due to the fact that it's created that the virtualization is done here on a different approach. Right. So for instance, as usual, we have the physical hardware at the bottom, and then we have the operating system to manage it. So this is what we got. Right. On top of the host virtual machine, now what we have is a container engine, right? Container runtime. Instead of hypervisor, what we are having here is called container runtime that typically uses the host operating system itself to create this isolated environment called container. Right. So these lives that we are seeing, these lives that are typically, this isolated environment was what we are seeing. These are actually using the resources of the host operating system itself, right? Right. Right. So now this is a much more detailed depiction of what is virtual machines, and then what we call as a containers. So primarily we have the physical hardware. On top of that, in the traditional VM, we have hypervisor. Right. We have hypervisor. This hypervisor logically split these resources into multiple logical resources. Right. Like I mentioned, it is about splitting the CPU, single CPU into multiple CPU. So in this case, it will split single CPU into three CPU, right? To understand, right? So that each virtual machine will get one CPU, something like that. So logically splitting the physical resources to create multiple virtual environment, right? So this is a typical virtual machine, right? So the hypervisor will do the task. This is a traditional virtual machine virtualization process. Now this is the containerization process. So where we have, as usual, we have the physical machine, and then we have the host operating system. On top of host operating system, instead of hypervisor, what we use here is something called container engine. So this container engine will use the resources of the host operating system itself, right? And then it will create a isolated environment. So typically it will create an isolated process. So the container itself will run as an isolated process in the host operating system. So meaning process of this is completely isolated from process of this. So this will get its own host resources. This will get its own host resources isolated entirely from process of other VMs, and typically the same thing here, right? So hence we are calling it as a lightweight virtual machine, right? It is also virtual machine. When we say container, it is also a virtual machine, but it is a lightweight virtual machine due to the fact that it uses this approach, right? Right. So now we can see the terms, right? So we saw operating system, containerization, containers. Now, how exactly we create containers? So now we somehow understood the concept here, the idea here, right? So we have applications that we need to run across multiple environments, and then so we have challenges in it in order to make this application to consistently run. And the solution is containerization. So we need to create container, and then we need to port container. Now, how do we create containers? So that is where we have a tool called Docker, right? Right. So here you can see you are mentioning something called container engine. So the duty of creating container, the duty of container engine itself is to create containers, right? How to create these containers, right? So the what we are calling it as a container engine. So typically Docker is our container engine, right? So Docker is a container engine which helps us to create containers, right? So Docker helps developers build, share, run, and verify applications anywhere without tedious environment configurations or management, right? So this is what it has to say. The official website of Docker has to say about Docker, right? So what exactly it is, like I mentioned, it is a containerization platform, right? So Docker is a containerization platform that allows developers to create, package, and deploy applications in isolated and portable containers. Typically, Docker is how we are going to do that containerization, right? So we are going to create, so we are saying bundling the application along with the dependency. So how are we going to bundling the application along with the dependency? It is not only about bundling and bundling the application along with the dependency, which is the primary role of the developer and those who are going to create the applications. Now what about user perspective, right? So if I want to run an application, how can I run the how can I run an application in my machine? For instance, I want to run Java in my machine, right? But I don't want to get into the complexity of installing Java in my machine, right? Or rather, I want to run MongoDB in my machine, but I don't want to get into the complex. This is from a user perspective, right? So when I say bundling the application, it is more from a developer perspective. Now, from a user perspective, as a user, I want to run multiple applications in my machine, right? For instance, I want to run a React application in my machine, but I don't want to install Node.js. How will I be able to do it, right? So typically, I look for these Docker containers that ports Node.js, that ports Java, or that ports MongoDB. So I typically need to find a container that has MongoDB in it, a MongoDB container. So what will happen if there is a MongoDB container that is there? I will typically pull that container and then run the container, right? So instead of installing MongoDB in my machine, so that is how this works. Uh, can I proceed? Do you have any questions so far? I know I'm speaking fast. I don't want to, waste the time that we have. Right. So, yeah, so we know containerization, what the problem containerization solve, and how we get to create the containers is through Docker, right? Right. So now the scenario change, a typical scenario change. Now, so we can see here, earlier code is getting ported. So we'll get into a scenario situation like this where we'll get errors in the target machine, right? So now we are just porting the Dockers, right? We are just porting the Docker containers rather, not Dockers, right? Yeah, right, a simple conversation that helps us to understand this, right? So can you help me launch the project? So I'm asking the client that you need to install the npm, right? So he will be then I need to tell the question will be what version of npm that needs to be installed, right? So developer itself know what particular version has to be installed, something like that. So this is how the conversation goes for me to make a client to run an application. Now this is not the case, right? So now if a client wants to run my application, I'll simply say run the command, run this docker command. He'll run the docker command and the application will get run, right? So now he don't need to worry about npm, he don't need to worry about java, what version of java that is to be used to run the application, whether I know whether it requires a database or scheduler, whatever it is. So we don't that details we don't that will not be involved in the discussion. It is only about simply running the docker command, the application will simply run, right? So but the only thing that needs to be done here is that we need to install docker in all these machines, right? So for us to be able to execute docker, for us to be able to execute docker containers or other run docker containers in all this machine, the only thing that needs to be available in all this machine is the docker, right? So if docker is available, we should be able to run any application without any hassle, right? Right. So now, when we install Docker, so this is a typical tools that we get along with Docker. So like I mentioned, so we need to install Docker, right? For us to be able to work with containers, we need to install Docker. So as we install Docker, this is a typical thing that we get, primary things. So one that we get is a Docker CLI. So which is what we are going to use to speak with the Docker itself, right? So whether to create a container or run a container, right? So create a other things, create a network, create a volume, create a image, whatever it is. We are going to see all those things now. So whatever that we want to deal with the Docker, just like a CLI that comes with any application, Docker also comes with a CLI, right? So this is the primary interface for building, running, and managing containers, right? And who is going to do the job within Docker? So it is the Docker daemon, right? So Docker daemon is the one that is going to run in the background all the time, and that is the one is going to manage the container and images, right? And how this once the container is triggered, so what tool is going to manage this life cycle, right, internally by the Docker, right? So there is something called container daemon, right? So these are some of the tools. And apart from this, so we have one important tool called Docker Compose and then Build Kit, right? So Build Kit is how we get to manage the building images, right? And then Docker Compose is what we use to run a multi-container application, right? So at a time, in modern cases, so we want to run multiple containers at the same time. It is not only about a single container, right? Multiple container at the same time. For instance, in the typical full stack application, so we need to run the front end like I mentioned earlier. It will be having a front end, it will be having a back end, right? Or in a typical microservice architecture, it is not going to be a single front end or back end. So you'll be having multiple backends. We call them as microservices. Now we have micro front ends, meaning it is not going to be about single front end. We are going to have multiple front ends, and then we'll be having a polyglot database, meaning it is not going to be about single database. We will be using multiple databases, right? This is in a single application, right? And then we will be having a scheduler like Redis or Zookeeper, something like that, right? And then we need a messaging platform like Kafka or RabbitMQ, something like that. So now for me to run a typical full stack application, so I need to run multiple parallel applications. So meaning I need to start multiple containers. So how do I create multiple containers, or rather manage multiple containers at the same time? So that is where we have something called Docker Compose, right? So Docker Compose allows us to handle the multi-container applications, right? So where we say where we I rate a configuration like what are the container that I need to start, and then I say Docker Compose up. It will typically run all the containers at the same time, right? So it will pop up 5 containers or 10 containers at the same time, depending upon our configuration that we have written in the Docker Compose file, right? Right. So now if you are getting started with Docker, these are the things that you will be starting with, right? So right now, how do we install Docker? Typically, we need to go to the Docker website, docker.io, and in the download page, we need to download the Docker, right? So if it is Windows, we need to download Docker Desktop for Windows. If it is for Mac, we need to download Docker Desktop for Mac. And if it is no, Ubuntu, we typically need to download a Debian package and then we need to install it, right? So in either cases, in all these cases, we'll get a installer that if we run, it will in sequence of steps, we will be running the installation, right? Right. So only the difference is here is in Windows, right? So in Windows, so typically Docker is we are saying that operating system containerization works by leveraging the host operating system, right? Leveraging the host operating system. So which cannot be done in the Windows, right? Which cannot be in the Windows. That is applied only to a Linux OS. Right. So now how do we make Docker to work in Windows? Is that some is Windows users or Docker desktop that comes for Windows is has something called WSL, right? So Windows subsystem for Linux, meaning Linux will get integrated with our Windows itself, right? So this we don't need to do separately. Once we install Docker, this setup is also done. So if I install Docker thing, if I have a Docker installed in my machine, then we'll also have a Linux subsystem. I mean, a Linux system will also integrated with our Windows, right? So now this Linux will be used for this Linux that this will run parallelly with the Windows, right? So this Linux will be used for creating the containers, right? So typically need to go to docker.io, right? If you have to start, you need to say docker.io, right? Docker.com. So you can find the download page here. I'll say Docker installation rather. Right. So you can install, you can download Docker from here and then you can install it. So for Ubuntu, something like that. Right. So once the installation is done, what are the next sequence of steps that we'll be using is to verify whether Docker is installed. These are some of the initial commands that you can start with. Right. So probably, so I'll open my terminal. Right. So once the Docker is installed, the Docker CLI will be available. Right. Docker CLI will be available, and then it can be it will integrate it with our native terminal itself. Right. So there is no separate Docker terminal. Of course, we'll get a Docker GUI. Right. So now, if you install Docker desktops, you'll get a GUI like this, modern GUI like this. This was not from the beginning, right? So this was not available from the time Docker was available from the beginning. This was recently, not recently, but for some times now, we are having this desktop GUI client as well, right? So where here also you can manage the containers, images, volumes, and other things, right? Right. Or other, we will use the Docker CLI, right? So whatever that we are doing in Docker CLI, you should be able to do it in Docker desktop GUI as well, right? So I'll say Docker. So I've already installed Docker in my machine. I simply need to say Docker version. So Docker is installed in my machine, right? So Docker Compose also comes with Docker itself. So Docker Compose is the one which we were I know which I told that to use to start to run the multi-container application, right? Docker Compose. Right. So Docker Compose will also be available. Right. So now I need to run a container. I have Docker installed in my machine. I need to run a container, right? And so whatever the container might be, I might be wanting to run a MongoDB container, or I want to run a Java container, for instance, right? So I'm having a Java program, but I don't want to install Java in my machine. So rather, I want a Java container for me to run my Java application. So how do I do it? So what is need for me to run a Docker container, right? So what we need is something called Docker images, right? Right. So what we need is called Docker images. So for us to build a Docker container, we need to have something called Docker images. So Docker images are, it's like a templates, right? Right. So these are the templates. So these are the core building blocks of the Docker container. So it typically contains the code, runtime, libraries, environment variables, and configuration files. Whatever that we require to build and run the container or run the container, it is it will be there in the Docker images, right? Um, so Docker images, as you can see, follows a layered architecture. So images are built using a layered file system, right? Uh, so Docker file is how we create Docker images. So primarily to run the Docker container, what we need is Docker images. Docker images is like a template for creating a the container. This typically contain all the configuration, dependency, everything. And how this is getting created is through a layered architecture, right? Um, so for us to create a Docker images, we are not going to do that to start in the start video. We are not going to do that. We'll first see how we can run the container, and once we have a idea of running these containers, we will then see how we can create a Docker images. So how we typically will create a Docker images is through something called Docker file. So we need to create Docker file where we need to write configurations for us to create the Docker images. Right. So each configuration or each instruction that we write in the Docker file, it will create a image layer. Right. And another important nature of the Docker images is that it is immutable, meaning once the image is created, we cannot edit that image. Right. We cannot edit the image. We can only add an additional layer on top of the image. Right. So meaning whatever changes that we are doing or whatever instruction that we are writing to make changes in the image, it will not change the underlying image. What it will do is that it will use that underlying image as a kind of base image, and then it will create a new image, right? So this is a, you can see here, this is a, this also layered structure. So we have a base layer, we have a base layer on top of that. So base layer comes with the a primary virtual machine, right? So for instance, this is about running a Node.js application, right? A Node.js or any application, something like that. So for running a Node.js application, for running a JavaScript application, I need Node.js, or for running a Python code, I need Python installed in my machine. So how basically this image is created, right? How basically this image is created is that, so they'll take a base layer image that comes with the operating system. On top of it, they will add an instruction to install the necessary libraries. On top of it, they'll write instruction to install Node.js or Python. On top of it, now we'll write instruction to run our application, right? So this comes with multiple layers, right? So this is a case. Now for us to build our own Docker file, now for us to containerize our application, we need to pull a base image, and then we need to write instruction to run our application on top of that base image. And that is how we'll get to build a Docker image, right? So primarily the thing that we want to understand here is that for us to run a Docker container, what we need is a template that contains instruction on how to run the containers. So what is the template is called Docker images. So Docker images is a key, right? Right. Understanding Docker images. So in order to create an image, we need a Docker file. We need to create a Docker file, and then using the Docker file, we need to build the image. Right. So Docker file contains the instruction for building that image. And using this Docker file, we need to build the image, right? So the image will be having the image that is built will be having properties like tag and version. We can test the image, we can optimize the size. So based on the image size, um, we can get to include or exclude certain libraries or dependencies in order to optimize the size. And then now we need to make the image to be available to everyone, right? So this is a critical phase. It is not only about creating the image, right? So now if I want others to be able to create containers from my image, I should be able to find a way to share this image, right? I should be able to share this image. Only if this image is available to others, they will be able to create the containers. So how will I share the image, right? So now I understand what is image. Image is the one that is used as a template to build the containers, right? To run the containers rather, right? So now for everyone to be able to run create containers out of this image, how do I share the image? So that is where we are saying Docker registries. So there are Docker registries available. They are typically the online platforms, online library of images where we can share our images, right? Where we can manage our images, I mean Docker images, right? So another apart from images containers, the another important thing is called Docker registries, right? So these are the different Docker registries that are available, right? So primarily the default registry that we can get to use with the Docker is called Docker Hub, right? Docker Hub. So meaning whatever applications that we want to run, you can find the images in the Docker Hub, right? For instance, MongoDB, Java, Node.js, or whatever it is, right? So primarily, so I need to run a container. I need to run Java in my machine. How do I run a Java container? Typically, I'll go to Docker Hub, and then I'll search if there is any relevant images. Now this is Docker Hub, right? You can even search, you can even Google it, right? Docker Hub, you'll get this link of Docker Hub. This is a default registry, right, of Docker Hub. So now, like I mentioned, I want to run or rather MongoDB in my machine, right? For instance, I'll say Mongo, right? As you can see here, you have different images here, right? So you have a Ubuntu image, right? And you have a Python image. You have a no image for Node.js. You have an image for RabbitMQ, meaning I don't need to install RabbitMQ in my machine. If I want to use RabbitMQ, I don't need to install RabbitMQ. There is a RabbitMQ image available in the Docker Hub. So what I need, the only thing that I need to do is I need to run this RabbitMQ container. Right. So now, for instance, this is RabbitMQ. RabbitMQ is open source multi-protocol messaging broker. So this is used for asynchronous messaging, right? So this is what we use typically for building that chat applications, because the message has to be asynchronous. Like we'll also be using Kafka, right? For instance, now these are the images that are available, different images that are available, and then you also have informations on how to run this RabbitMQ in your machine. So now you don't need to install RabbitMQ. Rather, you simply need to execute this command. That's it. You simply need to execute this command. This command will automatically pull RabbitMQ. So meaning this RabbitMQ image that is needed to run the RabbitMQ container, the image need not to be available in the local, right? Need not to be available in the local. So the only thing that we need to install is Docker. The only thing that we need to do is we need to install Docker. We need to install Docker, and then we need to ensure the images are available in the Docker Hub. That's it. Now, what will happen if this command is executed? So this is a command to run a container. Run a container, right? If you could see here, it says Docker run, and then so here these are the options, right? So this is a container name. It says my rabbit, right? It is a container name, and then for creating the container, what image it is using? It is using image RabbitMQ3. So now this image need not to be available in the local, right? So now when you run this Docker command, Docker primarily will try to locate this image in the local. Docker primarily will try to locate the image in the local, or else it will automatically go and check in the Docker Hub and then pull the image from the Docker Hub to the local, and then it will run the RabbitMQ container in your machine. So the only thing that we need to do to run any application is to execute a single Docker run command. That's it. So if I want to run MongoDB, I need to say Docker run, and then I need to use corresponding MongoDB image. If I want to run Node.js in my machine, I simply need to say Docker run and corresponding Node.js image in my machine. So how do I know these images? You can explore these images and the documentation on how to use those images in the Docker Hub. So in Docker Hub, you will find a official repository for all the images. For instance, this is the official repository of RabbitMQ, and similarly, you will find official repositories for all the images. Right. Fine. So now, what are the other repositories? So this is typically a public repository. This is typically a public repository, and then if you want, we can also have our own private repositories, right? How we can do that? So we have Amazon ECR, right? So that comes with the AWS, and then with Google we have something called Google Container Registry, and then we can also have our own private registries, right? So it is not that Docker Hub is a default registry, right? Docker Hub is the default registry, all right? And apart from that, we can also use other registries, and we can also set up our own private registries. So instead of pushing our images to Docker Hub, we can push our images to the private registry, and then we can make others to use that images with some authentication, and that is how we can make this thing secure, you know securely, right? Right. So now we know Docker images and how basically Docker images is used for building the containers. So we will now, see launch some containers, right? We'll see how we can work with the containers, and then we'll move into Docker Compose, right? Right. Right. So Docker is running. I'll say Docker version. Once again, I mean, it is running. So to ensure you can actually install, you can check, use this command, right? So now I want to know before running any containers, now I want to know if I have any, um, containers that are already running in my machine, right? So now where do you refer to these commands? So primarily the Docker commands are are meant to be the basics now to work with the Docker. So where exactly you can refer to these commands is in the Docker website itself. You have Docker CLI command reference, right? So you can say Docker CLI command reference, or you can even find cheat sheets online, right? Where you can find these basic Docker commands online, right? See Docker CLI command reference, right? So you'll find this Docker command CLI reference, Docker build. So these are the different Docker commands, right? So for instance, the one that we executed is Docker version, right? So this is Docker version. The command name is Docker version. Docker version command prints current version and dependencies of the Docker components, right? So for whatever command that you need, you can refer to this official Docker CLI reference, right? This is in docs.docker.com, right? So now like I mentioned, so I need to know what containers that are already running. So I'll say Docker PS, right? I'll say Docker PS. Now this will list out if there are any containers that are currently running in my machine, right? So there are no containers running in my machine, right? So in case if there are any previously executed containers, meaning containers which were previously running, now not running, something like that. So I'll say Docker PS dash A, right? Dash A. So this will show display if there are any stopped containers, right? So this container is created earlier. This container is created earlier. Now this is stopped, right? Right. So once the container is created, you can you can anytime start stop. So if the container is running, you can say Docker stop. And if the container, if you want to run a previously stopped container, you can say Docker start, something like that, right? Now this the container is there. The container is there, which is already created and which once was running, but right now it is not running. Now how do you start that container? How do you run that container? I mean a container that is already created. You need to say simply need to say Docker start, and then you need to say the container name, right? In this case the container name is hw-1 or the container ID, right? So I'm not going to do this one right now, right? So we will do this for the container that we are going to create, right? So we'll start from container creation, right? Right. So now what I'll do, I'm deleting all these containers. I'll say Docker container. All right. I'm saying Docker container prune. So this will delete all the stopped containers, right? This will remove all stopped containers. I'll say yes, no. See, working with Docker, one thing is that it will actually use our store resources. So we need to ensure that we are doing this cleanup once in a while, right? So as you start new containers, every Docker run that we are doing, it will create new containers again and again. So it will, you know, we'll tend to lose our resources unknowingly, right? So once in a while we need to ensure that we don't have unnecessary containers that are there, so we need to remove it, right? Now I'll say docker ps /a, there are no running containers as well as there are no stop containers. Now I want to run a container, so I need to start with a simple container, a container that executes um, a small print simple information on the screen, right? So I'll say docker run, I'll say hello world. All right, so now what does this mean? In fact, there is an image called hello world. So how what can we understand from this? So I'm trying to create a container from an image called hello world, right? From an image called hello world. I'm not giving other options. If you want, I can give a name for the container, or if there are options that you can give, right? I'm not going with other options. So this is simply to test whether Docker is successfully able to run container in my machine. So for that, I'm taking a simple, I'm using a simple image, right? So this hello world image is there in the Docker Hub, right? Hello world. So this is the official image, uh, an example of minimal Dockerization, right? So how do you get to run this image? You simply say Docker run hello world. That's it, right? I'll simply say Docker run hello world. Enter. Right, as you can see here, Docker trying to find the image in my local machine. It is trying to find, unable to find image in image hello world latest locally. Right, it is now Docker is once we issue Docker run, it is trying to find the image in my local machine. In my local, it was not there. Right, in my local, the image was not there. So hence it is pulling the image from the Docker Hub. It is pulling the image from the Docker Hub and then it is creating the image, and then the image, the container is executed. The container typically print this screen, and then the container will stop. So one thing that we need to understand is that Docker runs for a purpose, right? Docker runs for completion, right? Depending, so whether the container is running or stopping, it depends upon the application that it is trying to execute. Right, so if the application that it is executing, if it is a short running application, once that is done, the container will automatically stop, right? Or if it is a long running application like server or something like that, then the container will continue to run. So it will depend upon what exactly we want to do, right? So docker containers typically run for completion. Once the task that is intended to do, once that is done, the container will stop. Now in this case, the instruction to this Docker container is to print this information in the screen. So once this information is printed in the screen, it purpose is done. The container will also stop, right? So now I'll say Docker PS. You can see here the no container is running. No container is running. But if I say Docker PS/a, you will find a container, and then the container was executing, but right now it is stopped. It was executed. uh, you can see status excited. It was but the container is executed sometimes back, right? So the purpose of this container is simply to print this information in the screen. Once this is done, the container is stopped, right? So now I'll say Docker images, right? Docker images. Now these are the images present in my machine. So I have some of my private images, and then this is the image that we pulled, right? This is the image that we pulled, right? So I have this container. If I say Docker container prune, it will remove all the containers, right? So if I want to remove a particular container, then I'll say Docker remove, right? I'll say Docker remove, and then I need to say something like this, right? So the container that I created, I deleted it. So earlier I deleted using Docker prune, which is a shortcut to remove all the unused containers. Now I specifically mentioned a container that I wanted to remove. Right. So now I'll do it do it again. Right. So I'll say Docker ps no running containers, Docker psa no previous containers, no previous containers, Docker images. These are my images available in local. So if I want, I can keep the images. If any of these images is used by container, we can keep those images. For instance, if I don't want any of these images, for instance, I don't want this image, right? So I'll say I'll copy this image name, and then I'll say Docker. So earlier I mentioned Docker remove, rm to remove a container. Now I want to remove an image, right? So I'll say rmi, and then I'll place a image. So now this will remove that image. So to list all the images that are there in my local, I say Docker images. Now earlier I was having 4 images. Now I'm having only 3 images. The fact that I deleted one image, right? So apart from so we saw Docker version, right? We saw Docker version, and then we saw Docker PS, right? We saw Docker container command. We saw Docker RM, right? And then we saw this is to remove a container, and this is to remove an image, right? We saw Docker images. This is to list out all the images. And then we also saw Docker run, right? This is how we create the container. Now I'll create the container once again, right? Right, Docker images. You can notice that hello world, right? Hello world is there, right? I'll delete the hello world to make it clear. So I'll say Docker. I want to remove image, and I want to remove this image. Right. One thing you notice here is that right, you'll be seeing a tag followed by this image name. You'll be seeing a tag here. It says I'm not mentioning any tag here, right? I'm not mentioning any tag here, right? So this is how we need to ideally we need to do this. Meaning these images will have multiple versions, right? These images might have multiple versions. How these versions are depicted in a typical image by tagging that image. So every image that you find in the registry, it will have a tag, right? You will see a tag called one. You'll see, for instance, if you go to Java images, right, or any application or runtime images, runtime images like Node.js, Java, C Sharp, whatever it is, you see. Uh, so you'll find images with different tags according to the versions. For instance, right now we are having Java 22, right? 21, 22, 19, 17. So you'll find different tags, Java tags, JDK tags with JDK images with these tags. So you'll see JDK 17, JDK 19, JDK 20, 21. So these tags are how we can get to choose a specific image version. So if we don't do, if you don't include a tag, then it will pull automatically the latest version, right? I mean the image one with the latest tag, right? So I'll say Docker remove hello world. Right, now I'll say Docker images. There are no hello world images, right? No hello world images. We have again moved to the start. Now I'll say Docker run hello world again to have the clarity. Hello world again. So I'm not using any tag. If I'm using tag, specifically I'm telling you have to pull the latest tag, or if you leave blank, it will automatically pull it will automatically pull latest tag unless until if you mention a specific tag, right? Docker run hello world, right? Again, see, even though we didn't mention latest, it is automatically trying to pull the latest, right? Right. So now the image, now that this image is used, so this images will be available in local, right? I run this Docker images. Now I should be able to see that hello world available in my local, and then a container currently not running, but earlier it was running. Right. Now this container is stopped. I don't want to create the container. Now I simply want to start a stopped container. Right. So Docker run will always create a new container. right? Docker run will always create a new container from an image. Now I want to run a stopped container, right? So this is a stopped container. I'll simply say docker start container ID, right? I'll simply say docker start container ID. So the content, it will be started. It will be started. The reason why we are not able to see here is that we are detached from this container, right? Or we should be able to see a similar output, right? So this is how you get to start the Docker container, right? Right. So now this is the idea, right? So you need to find, it is all about finding appropriate Docker image and then using Docker run to run the containers. Now, if I want to run multiple container, like I mentioned in a typical full stack application, it is about we need to run multiple containers. So meaning I need to issue Docker run multiple times. Docker run, Docker run. So I need to start my front ends. So I need to say Docker run with all the configurations. So I need to tell whether it requires a storage, what network it has to use. I need to set environment variables, right? All these stuffs, right? Right. So I cannot. It will be a challenging things to for me to do that, right? So meaning handling everything in the Docker run itself. So meaning the Docker run command itself will be very long, right? The Docker run command will be very long if you want to manage all these things like environment variable, storage details, all those stuffs. Now instead of that, what we can do, we can write all those things as a instruction in a file called Docker Compose, and then in a single Docker Compose command, we will be able to um, start multiple containers. Meaning instead of doing Docker run multiple times, we need to say Docker compose a single time so that it will start multiple containers, right? So that is about Docker compose. Now we'll see how we can build a image, right? How we can build a image, how we can push the image to Docker Hub, and then how we can run the Docker image, right? So, right. So for this purpose, I have created a simple Java program in my machine, right? Simple in terms, more simple, right? Typically, right. So here I have a simple Java program. It simply prints hello world in my screen, right? So this is about printing hello world in the screen. But if you see, I don't have Java installed in my machine. I don't have Java runtime, or I don't have Java compiler, right? I don't have JDK available in my machine, right? I don't have Java installed in my machine. So how do I run this? So what I'm going to do, I'm going to containerize this, right? I'm going to containerize this, meaning I'm going to create a Docker image, and then using the Docker image, I'm going to run the container. So how do I create the Docker image? You have this Docker file. We need to write Docker file. So it is about creating Docker file, right? So like I mentioned, each and every instruction that we are writing in the Docker file will create a new layer on that image. So what I'm doing for this purpose, I am using a base layer. OpenJDK 17. I'm using a base layer, right? So OpenJDK 17. In that, I'm setting a working directory, right? So when the container starts, what is going to be my working directory? So this app is going to be my working directory. And then what I'm saying, I want to copy this source file to this working directory. I'm saying copy. So this copy the Java file into the container. So I'm having this. So in the present directory, I have a file called, this is host. This refers to the host. In the host directory, I have a file. I mean, in the host directory, I have a Java file. I want to move to the present working directory, which is this, right? And then once this file is available in the container, what it needs to do, it needs to compile that file. So how do we get to compile the file? This is how we'll get to compile this file. So typically, this is what I do in my local machine. One, if the Java is available, this is what I'll do. I need to install OpenJDK, right? And then I need to set path variables to OpenJDK, right? And then I'll be compiling the file, and then it has to be executed. So this is the case with all the machines. For instance, if I want you to run this program, then how will you run? You first need to install Java, right? You want to install Java, and then there are so many Java that are available. It is OpenJDK, Oracle JDK is there, right? Multiple JDKs are available. So you need to download appropriate JDK, and then you need to install, and then you need to be clear on what version that you need to install, and then you need to set path variables, stuff like that, right? And then you need to compile, and then you need to execute, right? So whatever that needs to be done, whatever configuration setup, whatever that is need, we are configuring in a Docker file, and then we are building an image, right? And then once the container is started, what is that we need to do? We need to run the Java program. So this is how we run a Java program, right? This is how we run a Java program. So now I'm going to build the image, right? So this is same for any application, right? This is same for any application. So typically we need to pull a base image, and then we need to set a working directory, and then we need to copy our source files to the container. We need to copy to the container, and then we need to build the application. So we need to write instruction to build the application, and then we need to give instruction on how to run the application, right? So we need to pull the base image, set the working directory, copy your source files to the container. So now the source files are available in the container. Now what we need to do, we need to build that, right? So if it is Angular, we need to build that Angular project, right? So we need to say ng build something like that. If it is React, we need to we need to do a React build, something like that. So once the source is available, you need to build. So in this case, I don't need to build, rather I need to compile this, right? There is nothing much here for me to build. Yeah, I have a single class file, so I'm doing a simple compilation, right? So this is my build step, right? And then once the build is done, what I need to do, I need to run the executable, right? I need to run the executable. Now this will run the application. Now this is kind of a template for template for containerizing any application, whether it is an Angular application, whether it is a React application, whatever it is. Pull a base image, set a working directory, copy your source file, build your source file, run your executable. That's it. Right, now I have this instruction. Now what I need to do, I need to build the image, right? I need to build the image. So I'll say Docker build, right? I need to give a name for the image, right? So this is where I give the image name. So I'll say image name, for instance, image name, and then this image needs to be created. What is the source? For me to create the image, where is the instruction? The instruction is present in a Docker file, present in the same directory. So I'll say a period, meaning I want this Docker to find the Docker file in the present working directory, or depending upon the directory, here you can give the relative path, right? Right. So now relatively this Docker file is present in the same working directory. Hence I'm choosing a hence I'm issuing a period here, right? So now naming the image is a critical thing here, because this is how it will get to identify the registry, Docker registry, whether we are going to share this in Docker Hub, whether I'm going to share this in you know AWS, or whether I am going to share this in Google Container Registry or any other private registry. How it will be decided is based on this image name. So image name follows a pattern here actually, right? Image name follows a pattern, right? So what I'll do, I want to name the image. So the name of the image is going to be right. I'll say NTW 2025 hello world, something like this. This is going to be the name of the image, right? So I want to tag this, right? I'll say something like this. I want to tag this, or I'll say version number, version v1, or I'll say 0.0.1, something like this, depending upon the version, right? Depending upon the version, you want to add the tag here, right? So I don't use any tag. If I don't use any tag, automatically it will take the latest tag, right? Right. So now I want to mention where this is going to get shared, where this image is going to get shared. This is going to get shared in my repo, in my Docker Hub repository. So for this purpose, you need to have you need to have an account in Docker Hub, right? So this is my account uh, repository name, right? This is my repository name. Now I need to mention this is a repository name, this is the image name, and then this is a tag. This is a tag, right? This is a tag. This is the image name. This is a tag. This shows where this image, in which repository this image is going to get shared. I'm saying my repository name, right? Um, right. So now these are my repositories. These are my repositories. My repository name is this one, right? So and then you also need to mention, you also need to mention the registry. Now whether this is going to be in Docker Hub or AWS or no Google registry, that you need to mention. That will go here, right? Docker.io. So if I say Docker.io, this refers to Docker Hub. So in Docker Hub, in this repository, I want to have this image, something like that. Right. So now here I can, in order to keep things simple, I'm going to remove the redundant. So this is not required. Even if it is not there, it will automatically do add the latest tag. And then by default, Docker Hub is the one that register will be used, right? Give a minute. Is that fine now? Is the command visible now? Yeah, thanks. Right, right. So I removed that tag, latest tag, because that is redundant here. Even if I don't put latest, it is still going to add that tag, right? I'm going to, so this is required because I need to mention whatever registry it is, you need to mention what repository this image has to be shared. This is required. This is not required. So by default, Docker Hub is the one that will be used, right? Docker Hub is the one that will be used, right? So this is not required. If you are going to say docker.io, it is not required. In other cases, you need to mention the registries, right? So for instance, if it is a um, Google registry or some other registry, you need to mention the registry. For instance, you can see this is an image, right? And you see a different, right? So this is the image name, right? This is the image name, for example. This is the image name and it has a tag, and this is a repository. This is a repository, and this refers to the registry. This refers to the registry. Now this registry, this is a private registry created in Google container registry, right? So this is our project, and this typically is a registry. This is not Docker Hub. So if it is not Docker Hub, you need to mention the registry information. In that registry, Docker registry, what is the repository and the image name. So right now we are going to have, I'm going to use a repository in my Docker Hub. So hence this is not needed, right? This is for example, right? Right. For instance, if you see here I don't have other information because this is from Docker Hub. This is straight from Docker Hub, and then this is from official repository of Docker itself, Right, this is official repository. This is from official repository of Docker itself. Right, now this is the thing. So I'll say Docker build dash t. I'm tagging it accordingly. If you're not going to share this image, you don't need any of these things, right? If you're not going to share these things, you don't need any of these things. You simply need to mention a image name. In this case, this cannot be shared in any online registry. You need to retag it. For that purpose, you need to retag, meaning you need to rename the image later. Once it is created, you need to rename the image later for it to be shared in online registry. Right now, let me make it quick. Right, right, and then I'll say enter. So now this will build the image. Right, you can see here the image is executed. In case if there are any issues, any errors here, it will throw error. So now it is built the image. It has built the image. So I'll say Docker images, and then you can see here now I have a new image. Right now I have a new image. It says this is I'm the Knot9, which is my repository in my Docker Hub, and then um, this is the image. Right now I can run this. Right, I'll say Docker run, and now this time I want to name, meaning I want to create a container, right? So I'll say Docker run name, right? I'll say NTW hello world app 1. So I'm saying NTW hello world app 1, right? And then I need to use a image name, right? I want to use the image name. So here we can provide multiple other options. For instance, if you want to containers are actually stateless. By default, containers are actually stateless, meaning whatever once the container is stopped, whatever data that is used that will be lost. So how will you preserve the data in this case? You need to share your host folders, right? Share your host folders, right? So that option we can say, you can say dash volume. Using dash we can mount one of the folder of container with one of the folder of host, something like that. And then you can also set environment variables. You can also map port depending upon the application that you are running. You can also map port. So there are certain things, certain configuration that we can use here. Right now this doesn't require much configuration. I'll go with Docker run name. This is going to be the name of the container, and the image that I'm going to use is this, the one that I created. I am the Knot9 slash what is the image? This is the image NTW dash 2025 HW hello world, right? This is the image. This is the container name. I am creating the container. Press enter. Right. So there is a typo. You can see here I have a type error here. Right. So I don't want to retag it right now. I'll say Docker my. I'll build the image again. Right. I'll say I'm the Knot9. Right. Now I'll say Docker run. Right. So now I'm getting hello world from Dockerized Java. Right. Hello world from Dockerized Java. Right. So I have containerized this application. I have containerized this application. Now even without Java, you can see here I'm able to run a Java program in my machine simply by using Docker. Right. Because this application is already containerized. This application, it is already containerized. You only need to run the corresponding container. Alright, so now how do I make others to run this application in their machine? Now I need to share this image, right? I need to share this image. So I need to push this to a public repository if I want, or if I want to provide limited access, then I need to push this to a private repository. right? For instance, in most of our cases, we are pushing for internal purpose. All those images we are pushing to our private repository, right? So meaning if you say Docker run, it will ask you credentials. If it is a image from a private repository, it will ask you credentials, and only upon providing the credentials, the container will run in their machines. So that is how we can make this secure. On top of that, the Docker image that is being created, the Docker image that is being created, the Docker images that are being created, they are actually signed, right? They are actually assigned images, right? Meaning if even though if this is tampered, it will be invalidated, right? So that is how the Docker images are made secure. Right. So now how do I make it to available with everyone? I typically need to push this image to my Docker Hub so that anyone out there will be able to use it, right? So now these are my existing repositories. I have a free account here. In my free account, I can have one private repository and then I can have unlimited public repositories. So this is Docker Hub. Having an account, provided an account, you have an account, you can have multiple public repositories where you can store your Docker images, and then you can have one private repository, right? So I need to push the image, right? So before that, I need to say Docker login. So I need to say Docker login. So I already logged in, right? I already logged in, right? I already logged in. So hence it says Docker logout, right? And since already the authentication is done, it is now again without even asking the password, username, password. The login is succeeded because I already logged in, right? So I need to say if I want to log out, I need to say Docker logout. Meaning by default, it will try to log into Docker Hub. In case if this is for other registry, you need to mention the registry, and then it is up to the registry on how you can log into their private repository, right? So maybe there will be an option where you can mention on how to log in, or there will be other authentication methods that will be there. Maybe SHA key that will be shared, that will automatically figure out what registry that need to identify, something like that. Now in this case, I use simple docker login logout command. This will work by default with Docker Hub. I say Docker login. I am now logged into my Docker Hub account. Login succeeded. Now I can push, right? So I'll say Docker push, Docker push. This is the image I want to push. This is the image that I built locally. Now I want to push this. Not 9 NTW2025 dash SW and say latest. So if you're not putting latest, it will automatically insert latest. So this image I want to push. Press enter, and then using default tag latest. Since I am not using any tag here, it is using a default tag latest, and then it is now pushed. The image is now pushed. All right, now we can see this images is there, right? This image is now available in Docker Hub. So now this is a public repository. Public repository. Now, if you do Docker run, this will be automatically run in your machines as well, right? So what I need to do simply, now I delete this image from my local, right? I'll delete that image from my local. Docker RMI F09 NTW 2025 hello world. This time, right? So the conflicting is because there is already a container that is using this image, right? So first I need to delete the container, and only then I can delete the image. PSA. Right. So there are a couple of containers that are running. I'll delete these containers, all the containers. Docker container rune. Right now I should be able to delete the image. Right now the image is not there. Right now the image is not there. Now I'll do docker run again. Now provided this command, probably you can take a screenshot and then you can later try in your machine, right? Once you if you are install docker in your machine, you can try this out later if you want. Provided this command, this command can be executed in anyone's machine now. Since this image is this image is now publicly available in Docker Hub. So just like how it is running in my machine, you should be able to this should be able to run in any machine now. So now all you need to do is do a Docker run for us to run any application, right? You able to understand this, right? So we saw how to create a container, how to build a Docker image, and how to push the Docker, how to share the Docker image, right? Right. So apart from images, right. So we have Docker images, and then we have containers, right? And then what we have. So and then apart from this, right, Docker file is how we get to create the images. Apart from this, we have something called Docker network. So this is something that you can explore, right? So we have something called Docker network, and then you have something called Docker volumes. Docker volumes. So whenever we start a container, it will Docker will use it will create a new network, right? Docker network ls. Right now you can see here I have created three containers, and then you can see three networks are being created. So meaning individual containers will have their own network space, completely different from other containers, and then completely different, isolated from other containers, and then the host machine itself. So the container will have their own entire set of entire network space. Um, Apart from host machine and the other containers, right? So typically if you want, we can run multiple containers in the same network, or we can choose to run the by default, as it did, the containers will have its own network space like we are seeing here. And then we can also change the process, right? For instance, we can also make, instead of making an entire network space available for the containers, we can also make the container to share the host network as well, host machine network as well. As you can see, there is a bridge host, something like that, right? And then there are Docker volumes. So Docker volumes is the storage that we can use with the containers, right? That we can use with the containers. Like I mentioned, containers are stateless. Once a container is stopped, whatever data that it used, that will not be available. So now how do you preserve the data? So even between the container restart, I want to store the data somewhere. So this will be helpful for us to run, containers, database containers, for instance. Database container like MySQL container, or a MongoDB container, Postgres container. So once the Postgres container stop, the Postgres database will not be there. It will be deleted. Now, how do you preserve the data? So you can mount the Docker volumes, right? You can create Docker volumes, and then you can mount the Docker volumes. So Docker volumes will be available, right? So once you start the container, we can at any time you can attach or detach these Docker volumes, right? So Docker network and Docker volumes are the one that you can try out along with these things, right? Right. Um, so what are the next step that you can do? Of course, you can write your own Docker file for complex applications, right? Build and run custom images, handle volumes and network, like I mentioned. So there are several things that you can do with Docker network and Docker volumes. And you can even take a remote login to the running container by using Docker execute, right? Push pull your work to the Docker hub. So this will show your experience, right? To show others. Like we can show like our Docker images in the our Docker Hub account, which will radically increases our presence in the uh, I mean, which will radically increase our social presence. Right. And one thing that we can explore later, once you are very well accustomed with these things, the important thing that you can do is something called Kubernetes, right? So once you have multiple containers, how are we going to manage the containers, right? So I need to scale the containers, right? So I need to have multiple instances of my application, right? Or I need to reduce the instances of my containers, right? So use something called Kubernetes. This is used for container management, right? Right, and the important thing that you can do is Docker Compose, right? So this is for running multi-container application, right? Right, right. So now this is a sample Docker Compose file, for instance, right? This is a sample Docker Compose file. So this is a version of Docker Compose that is being used, and these services represents the number of containers that we want to start. So this is in this case, this is one container, this is one container, right? So I need to start two containers, and then with all these configurations. So this will be typically long, right? This will be typically long for a Docker run. For instance, if this I need to do it with Docker run, right? I'll say, right, give me corresponding Docker run commands for the above services. Right. So basically, this is a Docker run command. Again, this is one Docker run command. So this we need to run it in our command prompt multiple times. For instance, here I have two. This is about starting two services. This is about starting two services. Now in order to start the services, now we have configured things in the Docker Compose itself. Now if there is no such thing called Docker Compose is there. Now what is the only option that I have? I have Docker run. For me to run a container, Docker run command. Docker run command is the only option. If I want to run 5 containers, then I need to issue Docker run 5 times, right? And it is not only about running multiple times, it is also about how complex it will get these run commands, right? So if the options are large, this will also increase, right? Give me a Docker command, Docker run with environment variables. For instance, this is another Docker run, right? See, this is a typical Docker run command. So what I did, in our case, I just mentioned the image name, and then I mentioned the container name, and then if you can see here they are they are doing a port mapping, right? And then they are setting these environment variables for the application to run. They are setting this environment variable, right? Only in limited time you will see 4 or 5 environment variable. In most cases, you might be setting multiple environment variable. If that is the case, this Docker run command will get very complex. So how do you handle this? You simply create a compose file. You simply create a compose file where you configure things once. So this is one container that I want to run. This is one container that I want to run. And this is the image that has to be used. And these are the options. So whatever that is there in the run command, we are writing it as an instruction here. Typically, this is the same information that we are giving in the run command, right? This uses a network. I'm saying, so this is a network, common network, and then I'm explicitly telling that this container has to run in this network. Both this container has to run one network, all right, one network, and this is one container. Now what I need to do, provided this Docker Compose, I simply need to say Docker Compose up. That's it. Docker Compose up. It will use the Docker Compose file, and then it will start multiple containers at the same time, right? This is how um, run a multi-container application using something called Docker Compose, right? So this is something that you can also explore, right? Right. I think that's it from me. Thanks for joining in. I hope this session was useful to you. Like I mentioned earlier, the idea is to introduce ourselves to the concepts of Docker, right? So this might not be a complete bootcamp kind of thing, but I believe this will help you to start your journey with Docker and things, right? Uh, so that's it from me. If you have any queries, you can ask before we close. Yeah. So Tony, you need to answer that slide presentation slide.
For the presentation slide, I would need to verify because as far as I know, this recording can actually be viewed on our CEO's profile. You can actually see it from there, but I still need to verify if we're sharing. But from what I know, we don't. So
Okay,
since
fine.
this is a privilege for regular classes, if I'm not mistaken.
Right.
So if you have any questions, you can simply unmute your mic or utilize the chat box. So we have a question, sir, from uh, Amirul that says, "Can you share a bit different with Kubernetes?" Is that how you read it?
No,
And
yeah. So there is a question. So all these Docker images, they are actually backward compatible. So even the Docker itself is updated, it shouldn't affect the image. So all the old images, whatever that we have, it should get run with any Docker versions. Fine, Haryana. So Docker itself is keep on upgrading, right? Docker itself will keep on upgrade itself, but it shouldn't affect the images that we have created using earlier Docker versions. Right. So for instance, some of the images that I have, they are in fact old images. No, not every time. Not every time. So it will run in the background. So every Docker will update itself. You don't need to do that often on except exception cases. But we don't get to do that often. Right. So if you are speaking about cloud, so if you are running containers in the virtual machines, direct virtual machine, then it is a concern that you need to manage. But what we have right now is the container services. In most of the cloud, we have container services where you don't need to worry about the container engine like Docker or Podman, whatever it is. We don't need to worry about it. So there are container solution itself, container services itself, where you only need to provide the image, managing the container, what Docker, whether it is using Docker or Podman, all this will be taken care by the container service in itself. So if you want to run Docker container in cloud, then I would suggest that we'll go with the container services. Now we are in fact running using the container services like we are using Cloud Run in Google, and then in AWS as well we have a container service. So instead of going with a typical VM to run the containers, we will also, if the containers are stateless, of course, if you are running the stateless containers, then we'll also get to choose with container services to handle this update kind of thing, right?
anyone else who has questions?